Is from the official SAT study guide. We are on Test 3, Section 5. I just wanted to point out that the formula page here, this is what we talked about last time in class. We talked about, hold on a second, I need to get the appropriate pen. Here we go. We talked about these special right triangles, and they're right here in case you want to look at them. So x is across from the 30-degree side. Then you take whatever x is times the square root of 3 across from the 60-degree side, and the hypotenuse is always 2 times whatever x is, 2 times whatever is across the 30-degree side. And then here's the one for the 45, 45, 90. All right, let's dig in. Hopefully this won't be a super long video, though it might be. All right, Fred, Norman, and Dave own a total of 128 comic books. If Dave owns 144 of them, what is the average number of comic books owned by the other two? So first we have to figure out how many are owned by the other two. If there's 128 total, we're going to take away Dave's books, and we're going to have left over for the rest of them is 84. Now we want to find the average of between the two of them, so we're just going to take 84 and we're going to divide it by 2, and we're going to get 42 books. And that is number 1. 42. Okay, next one. In the xy coordinate system, we have a circle. It's tangent at the x and y axis. What are the coordinates? Well, circles are symmetrical. That one, because I stretched the picture a little bit, it doesn't look very symmetrical, but it's a circle. This radius going from here to here is going to be 6. Whoops, I missed that. Let's get this one. There we go. So we know that this distance right here is going to be 6. This radius here is also going to be 6. This is going to be 6, and this is going to be 6. So the coordinate of P is going to be 0, 6, and that is answer B. All right, onward. Okay, a hotel charges a service fee of $1, so $1 plus 10 cents per copy. So we're always going to start out, no matter what, it's going to be $1 if you're going to use the machine, and then we're going to add something to the $1. So here we have, there's no $1. Well, it could be that, but let's just keep going. $1 plus 10 cents per day. Well, this would be $1 plus $10 per day, so that's not going to be it. Then we have $1 plus 10 cents times n. N would be the number of copies, and that is the 1. Let's just go on from there. Hold on a second, let's turn the page. All right. In the 6 pairs of letters shown above, if A is paired with itself, it has a value of 2. If A appears with another letter, it has a value of 1. All other pairs have a value of 0. What is the sum of the values of the 6 pairs? So if A is paired with itself, it gets a value of 2. So I just put a 2 there. Is there any other A's with itself? Yes. If A is paired with anything else, it's going to be a 1. So we have an A and a B, an A and a C, and a B and an A, and it has no value if A is not in it. So we're just going to add those numbers up, and we get 7. That was a pretty easy one. Let's go on. What is the area of the square above? Well, this is our special triangle rule. Squares, all the angles are going to be the same, and the diagonals are going to bisect the angles. So we know this is going to be a 45, 45, 90 triangle. We also know squares have 90-degree angles. So one side is going to be the hypotenuse divided, because it's going to be smaller. The one opposite of the 45-degree angle is going to be smaller than the one opposite the 90-degree angle, so we're going to divide by the square root of 2. You can rationalize that if you want to, but we're going to find the area of a square. And remember, the area squared is side squared, so it's going to be 4. We have the one side, square root of 2 squared, so we get 16 over 2, and our answer is 8. So if you know that rule, it's pretty easy. You could also use the Pythagorean theorem, calling this side x and this side x, but it's definitely a lot more work. So we're going to go with that answer. 6 through 8. This one's a little tricky. If x is not equal to 0 and x is inversely proportional to y, which of the following is directly proportional to 1 over x squared? Well, it says that x is inversely proportional to y, which means x is going to be 1 over y. That's inversely. It's not directly proportional, it's inversely, so the y has to go in the denominator. So then I'm going to take this and I'm going to plug it in for our x squared. So we get 1 over y squared. And we get, if I put in all the steps, 1 over y squared. And I would flip the denominator and multiply. So we get y squared. And that is the answer. Thing to keep in mind is if they say inversely proportional, just put the thing that's inversely proportional to it over 1 or flip it. It was an easy problem if you knew what you're doing. Okay, find point A is on the vertex of an 8-sided polygon. The polygon has 8 sides of equal length and 8 angles of equal measure. When all possible diagonals are drawn from point A in the polygon, how many triangles are there? Well, one way is to just start drawing out the 8-sided polygon, which is going to be an octagon, right? So let's just do a quick sketch of this. Don't have time to draw straight lines, really. Okay, so we're going to see how many triangles. So we would have 1 triangle, 2 triangles, 3 triangles, 4 triangles, 5 triangles, and 6 triangles. So the answer is 6 triangles. The other thing to know is if you have a polygon with 8 sides, the number of triangles is always equal to the number of sides. This is the number of sides minus 2. That saves you a little bit of time, as long as you can be confident. So there's 8 sides minus 2, so there's going to be 6 triangles. The number of diagonals would be the number of sides minus 3. So there would be 5 diagonals. Okay, next one is a chart. No, it isn't a chart. Huh. Okay, this one is a really complicated and fun problem. In the equation above, k and m are constants. If it's true for all values of x, what is the value of m? Well, here's the key. It's true for all values of x. So you can pick any values of x to put in there. So I'm going to say let x equal 0 and see what we get. So here we go. If I put 0 in, I'm going to get negative 8. 0 in for x, I'm going to get negative k. And we're going to get, for this, we're going to get 0 minus 0 equals m. So we're going to get m equals 8k. So we have 2 variables now instead of 3, so we need 2 equations. This is going to happen, I've seen this several times on different SATs. It'll say true for all values of x. If that's true, you can pick any value of x and put it in the equation. So now I'm going to pick another value of x. I'm going to pick, let's pick 1. So x equals 1. So I'm going to put that in there. 1 minus 8 is negative 7. 1 minus k is just 1 minus k. And 1 squared is 1 minus 5k, because x is 1, plus m. And I'm just going to clean this up a little bit. I'm going to say negative 7 plus k equals 1 minus 5k plus m. And let's just get it in some sort of manageable format. I'm just going to solve this one for m, since this one's solved for m. So I'm going to bring everything to the left. So you get negative 8 plus 6k. Let's see, did I copy some number wrong? Hold on one sec. Negative 7 plus, oops, I forgot my 7k right here. I didn't distribute that very well. Okay, so we're going to get, let me just cross this out here. So we're going to get 12k. These little mistakes are tough, so make sure you distribute that. Equals m. Now we have m is equal to this, and m is equal to that, so we're going to set them equal to each other. So we're going to get 8k equals negative 8 plus 12k. And now we have one variable and one equation, so now it is very solvable. Whoops, I just lost it. So I'm going to subtract 12k from both sides and get negative 4k equals negative 8, and we get k equals 2. Okay, let's go back and see what the question's asking for. The question says, what is the value of m? Well, we found the value of k. So we're going to just take it right into this equation. We're going to take m equals 8 times 2, and we get 16. That was a tricky one. And it's once you discover that you can put in any values for x, it's not quite as bad. Yeah, it was difficult. All right, let's go to the grid-in ones. So that always starts in number 9. And you notice in this section, they get hard quicker. They start out, I mean, by 8, we're at the hardest problem. And this is probably a level 5. And then, when it starts over, it's going to start at an easy problem again. So just be prepared for that. The grid-in sections go easy, hard, and then back to easy, hard. All right, flying at a constant speed, a bird traveled 62 miles in 4 hours. 62 miles in 4 hours. At this rate, how many miles, we don't know that, did he travel in 3 hours? They're proportional because they're at the same speed. There's a lot of proportions on SATs, a lot of ratios. So you can just cross multiply and do this or reduce it. I think I just did mine in a calculator. I took 3 times 62 and did 4x. I divided this by 4 and we got x equals 46.5. Not a very satisfying answer. You don't even need to put units on because you can't put units on the grid-ins. All right, P, Q, R, and S lie in a circle with center P. So we need to get ourselves a circle. Center P, find the center somewhere. The radius of the circle is 1. What is the value of PQ? And these points all lie on the outside of the circle. So we have Q, R, S, T, and they want to find the value of, this is P, PR plus PQ plus PS plus PT, and it tells us that the radius is 1, so it's going to be 1, 1, 1, 1. So you add those up and your answer is 4. You might have got by without drawing a circle, but I just did that to explain it. Okay, next ones. All right, there it is. Okay, this one says, you can't see it very well, 10 to the AB equals 10,000. Thing you have to know is 10,000 is the same as 10 to the 4th. You need to get the bases the same. So we have to get AB, A times B has to equal 4 because 10 to the 4th power. So what are some possibilities? You could have 1 times 4. You could have 4 times 1. And you could have 2 times 2. So for A, you could have the answers 1, 2, or 4. All 3 of those answers work. Okay, let's go down here, xy plane. We have 2x minus 3y equals c. And we have the point 5, negative 1. Points are always your xy values. So do you want to find the value of c? Well, they're giving you your xy values, so you're just going to plug them in. So you get 2 times 5 minus 3 times negative 1 equals c. 10 plus 3 equals c. And we get c equals 13. So this one's just checking to see if you know that points have xy, or the xy's in the equations. Okay, here's our chart. The scatter plot above shows the number of male and female students at Central High School from 1990 to 1999, and which one of the years shown was the absolute value of the difference between the numbers of male and female students the greatest. All right, you can start looking. This one, the bottom, the x-axis is the male students, the y-axis is the female students. So if we go to 1990, there are 600 male students and 600 female students. So if we subtract them, we're going to get 0. That's not very high. If we do 650, 1991, you have 650 male and 800, where's the female? 700 female, the difference is 50. I'm not going to do all of these, just show you how these set up. In 1992, you have 650 males and 800 females, so the difference is 150. Now we can keep going here, so we're going to get, we'll just do these more in our head. So here we have 750, 750. That's not going to work. We're looking for something greater than 150. So we have 750, 800. That doesn't work. Here we have 850, 858. That doesn't work. 859. That's 100. Here we have 1,000, 1,000. That's not working. 1,100, 1,100, or 1050. And that's only 50 different. And here we have 1150 and 1100, so that's only 50 difference. So this one here has the greatest difference, so you would just put 1992. Okay. 5 times a number is the same as the number added to 5. So this is a simple algebra 1 equation, so you get 4n equals 5, n equals 5/4. Or you can change it into decimal when you grid it in. Okay, we're moving quickly on this lesson. All right, that was, let me see if I can find the next one. Hold on a second. Ah, here we go. So we are on the last page. Waiting for it to load. Okay, this one here, these are, of course, the more difficult ones. They're at the end of the grid in, which I think are the hardest ones on the whole test. So here we go. In the figure, it's not drawn to scale. It would be really nice if it was, but you're going to see it's really not drawn to scale. OD bisects AOF. Just all the letters drive me crazy on this one. AOF. So which one bisects it? OD. All right, so this one, I'm just going to put marks in it. This one bisects these. All right, got that. I am tempted to use color here, but you can't use color on the SAT, so I won't use color either. OC, this one right here, bisects AOE. AOE. All right, so that means that this one, I'm actually going to use double lines instead of slashes because the slashes are going to get lost in the with all the other vertical lines that would go through it. So I did double slashes for that. Or you could do thicker lines. And then finally we have OB. Here's OB right here. Just mark it for myself. OB bisects AOD. AOD. So here we go. Now we have, I'm just going to bring this guy out a little bit further and just do 3 lines through. I mean, you could put 3 slashes through too. That's fine. It just gets more confusing in my mind. Oops, I'm not very clear on this. Okay, so we have all that. Now we have some things. X equals 40. Yikes, I don't think I can write in here. 40. And Y is 30. Okay, now what do we have? Do we have anything? This one is 40. And here we're going so quickly, and now I can't see what I did here. Yeah, we have this one and this one are the same. That doesn't help us at all. This is 40. Hold on one second. I might have marked my diagram wrong. I think I did. I marked the last one wrong. That was my problem. Let me just see if I can erase this. I'm just going to take this out. Oh, that looks bad. Okay. All right, that was bad. Marking your diagram wrong is not a good thing to do. Okay, so let me just check something here. Let me just go back. I knew I wouldn't make it through a whole video without a problem. Okay, let's do the last one. OC The last one, OB, this one, OB, bisects AOD, AOD. There we go, AOD. All right, so because it's not drawn to scale, that's what throws you. So this line right here bisects AOD, so this one, there we go. Now our problem is solved. Do you see how the not drawn to scale looks really bad? Yikes. So they're supposed to be the same. Now we can go down and do all these other ones. So this is 40. This is 30. So this guy and this guy are the same. So this angle right in here is going to be 40. It doesn't look the same, but this drawing is not drawn to scale. All right, now we know this guy right here and this guy right here are the same. So this angle is 80, so this one has to be 50. There's more information than we needed in this one because we don't really need to know this one or this one. So now we can answer the question, I think. BOE. BOE. And you can see BOE is 40 plus 50, so the answer is 90. Okay, lesson that story is make sure if it's not drawn to scale, you don't try to marketing it according to scale. Okay, all positive integers appear in the sequence above, and each positive integer k appears in the sequence k times, and the sequence each term after the first term is greater than or equal to each of the terms before it. If the integer 12 appears in the sequence as the nth term, what is the value of n? Okay, I'm kind of assuming that you guys work through these problems, that you tried them yourself, and you already are familiar with the problem. So that means there's going to be 1, 1, there's going to be 2 2s, 3 3s, 4 4s, 5 5s, 6 6s, 7 8, 9, 10, and 11 11s. We want to know where the first 12 appears. Well, after you figure out all the 1s, 2s, up to 11, and then the next one is going to be the first 12. So all you have to do is add the numbers on your calculator, 1 through 11, and you get 66. So this equals 66. And then you're going to start with your 12s. So there's going to be 12 12s, but the next 12 would be the next number. So the answer is 67. Okay, hopefully you got that. And the next one, one end of an 80-inch long paper strip is shown in the figure above. The notched edge shown in bold was formed by removing an equilateral triangle, which is very important, from the end of a 4-inch length on one edge of the paper. What is the total length in inches of the bold notched edges of an 80 strip piece of paper? Well, if we take one sequence, so let's just take one pattern group. So here's one pattern group. How many pattern groups are we going to have? Let me just put this in black here a little bit. Here's one. So, well, let's figure out how long a pattern group. A pattern group is going to take 4 inches long. So we're going to take, for an 80-inch strip, there's an 80-inch strip, we're going to figure out how many patterns there are. So if each pattern is 4 inches, we're going to divide it by 4, and there's going to be 20 of these patterns in a 80-inch long strip of paper. So here's the pattern. It's a line with this notchy thing. We want to figure out how long this line is with the notchy thing. So we're doing the what's it say? The notched edge. What is the total inch of the bold notched edge? Well, we know this is 3. We know this is an equilateral triangle. So if this is 1 inch, then all the sides are 1 inch. So that's 1 inch, and this is 1 inch. So it's going to be 1 and 1. So one pattern thing is going to be 5 inches. How many pattern things do we have? We're going to have 20 of them because there's 20 of these, because each length is going to be 4 inches. We divided it into 80. There's going to be 20 of them, so I'm going to take it times 20, and we're going to get 100. So the length of all the bold for 80 inches is going to be 100. It's always much easier when someone else does it. Okay, last problem. In the figure above, PQRS is a square. Points Q, R, and O lie on the graph where A is a constant. If the area of the square is 64, what is the value of A? Okay, here's the first clue. Area of the square is 64. So we know that a square, all the sides are the same. So what squared gives you 64? 8. Every side is equal to 8. So down here it's going to be 8. Now, the parabolas are symmetrical, so that means 4 are going to lie on this side and 4 on this side. All right, we have this equation, y equals ax squared. We can figure out the coordinate of these points, like r is going to be over 4 and up 8. Q is going to be to the left 4, negative 4, and up 8. We can figure out the other coordinates of P and S, but we need to know where A is a constant, what is the value of A. So this is the parabola right here. Right here is our parabola. So we need actual XY points that are on the parabola. So remember we talked about before that points are always XY. So once you have them, you can plug them in and get the missing variable. So you can take either this point or this point. I prefer to leave the negatives behind. So we're going to get 8 equals A times 4 squared. And we're going to get 8 equals 16A. A equals 1/2. And that is how you solve that. All right, so that is it for SAT test number 3, section 5.